and he's not online. So I will just I will just go uh, and talk about some helpful thing uh, to help you about the challenge, the competition. Yes. So this time, so first of all, I hope you are all doing great on the competition. I saw some of your submission, and to tell you the truth, I am happy. Yes, I am just happy. So I wanted you to continue in that way, and now I will just also share some of the things that will help you during the competition. So what will I do is let me share my screen. Uh, yes, where is that? Um, yes, so I wanted to talk a bit about. So normally the talk should be about how to stack your model, but this time I want to talk about the stacking itself uh, as a model to help you in the prediction. Yes, for your competition. So this time, why do I want to talk about this? Because the competition are not about how commented, how structured your code is actually, but it's just about how your code is actually performing. So it's more related to the accuracy of your prediction. Yes. So if they ask you to submit the format, so your model, the big issue on the competition is how to make your model performing very well. So you are in the competition, you could just be asking doing prediction, using regression, using classification. And as you already know, there are also a lot of machine learning model to address the problem depending on the nature of this problem. So this time, uh, so we did a lot of tutorial on machine learning, for example, random forest, decision tree, SJ boost, yeah. So logistic regression, k nearest neighbor. So there are a lot of models either for classification uh, or regression. And all those models, every of those models can just have some skills, can just be skillness in your problem solving process, depending on the data you have, depending on the model itself, depending on the nature of the data set, the structure, all those things. So you just know that by running a lot of model, one of them could just be, yes, could just more perform than the other. So if you actually decide to, if you are running in a regression problem, for example, and then you decide to run to make, let's say, linear regression model, and then random forest for regression, and then decision tree for regression, and then SGBoost for regression. And so it's about four model, right? So one of them will just perform more than the others. And so if you want to classify your model in terms of performance, you will just have a rank for all of them. So now the thing is, There are models which are not using aggregation, and there are also models which are actually using aggregation to make a prediction. So the model which are not using aggregation, logistic regression, k-nearest neighbors, how to say, and about the models which are actually doing the prediction from the aggregation of a lot of model, we have random forest, and so which is the well-known, and it's actually an assembly learning technique because it's combined a lot of decision tree model, but there is the decision tree itself. So the decision tree sometimes will just perform better than random forest, which is actually combining a lot of decision tree. And but when you look at the random forest, is it should perform better because it's actually aggregating the result from lot of model. So each of those model is actually a decision tree model. So normally it should perform, and so that's why it's so useful and so popular because it's used to give very good result without putting lot of efforts. So now today, uh, what I want to address is, and I will do that quickly. So what I want to introduce you to address is, what if the model we are actually, what if we have a lot of model, like just we have random forest itself, we have decision tree, we have supervisor machine, we have logistic regression. So we have a lot of model, and we want to make an ensemble learning model from all those models. So what random forest is actually doing is just aggregating results from a lot of models. But all those models, each of those models are actually decision tree. So the general remark is that those models are of the same type. But what if the models are not of the same type? Which is like we want to use regression the result from logistic regression, combine this result to supervisor machine, and combine to uh, decision tree, and combines to random forest. So we have a lot of model, and then we have a lot of different kind of model, different type of model, a very big variety, and then we want to just predict from the performances of those models, because each of those models are actually performing, uh, they are performing, but do they perform better than the ensemble learning? Like if we combine the result of all those models and want to actually make a prediction, will they perform better? So that's a question. So this question is actually what the stacking ensemble learning, machine learning will try to answer. Yeah. So this is what it will actually try to answer. And so why? Because yes, there are a lot of models, and can we actually use those models in terms of so different kind of model to actually make a prediction? So this is why what I want to talk to you about today. And the model that which can be used to actually do that is actually called stacking. Uh, so stacking is an assembly learning machine, yes, as at the same level as random forest, but this time is using not a kind of the same type model to aggregate the result from. So it use a meta learning algorithm to learn how to best combine the prediction from two or more base machine learning algorithms. So when you are using stacking, there are two things to know. So the first thing is related to the base machine learning algorithms, and the second thing is related to the meta uh, machine learning algorithm. So the base machine learning algorithm are the one you use to train your data. So like if I want to compare that to the decision tree, yes, I would say the base machine learning algorithm is actually here the decision tree, because a random forest will actually combine a lot of decision trees. So each decision tree is an algorithm. So it's actually performed to make prediction, and then the random forest will just aggregate this prediction from all those models to make its prediction. So now look at this decision tree as a baseline model. So it will serve as the baseline model in the stacking and some machine learning technique. Yes, so they are baseline model, but the only one difference is that this baseline model could just also be support variable machine. So it will be at least two model, because we need at least two model, two baseline model to take to do the aggregation. So one of them will make a prediction and the other one will also do another prediction, and we will combine the prediction to take the final decision. So now look at the decision tree, for example, as a baseline model, and look at also the support variable machine as a baseline model, and then from so linear regression as a baseline model. And so let's say we have three baseline model, and then we want to predict a target variables. So those each of those baseline model will actually do the task and then predict the target variables. So once they will predict actually the target variables, what will happen next? What will happen is the baseline, the what to say, not the baseline, the meta learning algorithm will just combine the result from all those baseline and then make its own prediction. So normally, imagine the process. If we imagine well, we can just like make the hypothesis that normally, if a lot of models are just making prediction, and one of the and the final model, excuse me, and the final model is just taking the decision from based on all those predictions from the baseline model. Normally the final model should just be like performing more than the other baseline models. So actually there are two things to know. So I'll not go through the test. I will just explain you, because I want you just to understand the kind of, and I know you already understand. So there are basically two things to get. So the level zero model are just the baseline model. So compared to random forest, they are actually the decision trees. So now the only difference is that we can have decision tree inside. We can also have logistic regression or linear regression or k nearest neighbors, or so different kind of model, not only the decision tree. Yes. So the baseline model, the base model could just be uh, explained as that. So model fit on the training data and host prediction are comparable. So I think on the training data, because it will take the training data as input and it will give now the output as the prediction. And now each of them will have an output, which is actually the prediction. And now this is where the level one model comes. So the level one model is actually also called the Metamodel. And this model that learn how to best combine the prediction from all the base model. So the meta model is actually trained on the prediction made by the base model. So this is the big field, because a model will always use some input and will have an output. So the base model, the level zero model will just use the training data set. So for example, last week we want to predict the 10 deposits. So it will just use the 10 deposit data set as it, and just like try to make the kind of prediction. So actually the output will just be the prediction. Yes, he will do a 10%. No, he will not subscribe. Yes, he will subscribe. No, he will not subscribe. So this vector of outputs will just constitute one of the features to the level one model, so to the meta model. Yes. And then if you have depending on the number of baseline of base model you have, you will just have this exactly this number of predictor for your meta model. So the structure is very simple. So you have a lot of baseline model, and then you have the results from each of those models. So each of them will just take as input the training data sets as it, and then it will compute the outputs. So the output will just be like the input for the meta model. So depending on how many base model you have, you will just know the number of features you will actually have for the meta model. Yes, and then the meta model will take the prediction from each base model and then combine all the prediction. It will make a new data set. It will make a new data set, and this new data set will just have features, but those features will just be the output of each base model, and the response variables will just be the response variable from the, let's say, the initial data set, initial training data set. And then this will train, this model will just train, and then it get the output exactly as the base model. So the output, the final output will just be compared to the initial training response variable to see like to assess the performance of the model. So the whole thing is just that. So it's here. Today I would just like to talk about the classification, but the process is exactly the same as the regression. Yes. So yeah. So this time, so we can use the mail classification function to create a synthetic binary class. Yeah, because we don't have the data set, so I want to create it like to generate it from here. So there is a function to actually do that, generate actually a classification problem. So you just have to put to fill your input. So the input, so the number of sample we want to have, the number of sample we actually want to have, the so the sample, the number of features, the n informative, the n so those. So the very important things are the number of features and this and the number of sample. But this is not important because you will have the data set to actually practice exactly. So you will have your this week your competition data, so you can just practice on that. So we generate the data using this function. So I generate like 1,000 sample and 20 features. Yes. So now, what are the baseline model we want to try? So there is logic. So it's a classification problem. So binary classification. So I will just test logistic regression as baseline. K-nearest neighbor can do binary classification. Decision tree, yes, it can do. Superviral machine, yes, and naive bias. So each of these algorithms will actually be evaluated using the default model parameters. So we'll just set up the model exactly like I did here, and we'll now see the evaluation things. So here it's just a function to actually define the evaluation method of each of those models. The whole thing is, yeah, so here I'll just, so we can then report the mean performance of each algorithm and also create a bus to compare the performance. So from your analysis, you already know that when you do a model, you will just like get the, you decide about the metric you will use to actually check about the performance of the model. And then if you are doing a lot of model, you will just like compare those models to actually pick a best one. And so this is exactly what we are doing. So all those concepts are nothing. The only one important thing I want to show you is this output. So it actually get the performance of each of them, and definitively you can see that the support machine is actually performing well here. But we want to introduce actually the stacking. So the stacking will just combine the result of this, and this. So normally it should like be better than all those models. But We never know if it's not better than all those model. We just use the base model to the prediction. Yes. But definitively, why I'm teaching you this today, because I know this week is about this week and the next week and the following. So they are about competition, and in competition, so we don't really care about how structured your code are, but it's really about how better your code is, like the performance of your code, the accuracy of your model. So what they're asking to predict and what you are predicting, are they looking like the same? So in terms of that, I think it's important to let you know that how to compare. Yes, the random forest model could actually do that, but all the model inside, all the base model inside are just decision tree. So how could actually you could actually use different type of model like the logistic regression, the k-nearest neighbor, the decision tree, the supervisor machine, the bias models to actually get like make a stacking model which will probably perform better than all of them. So now, so we have five different algorithms that perform well. So that, but somewhere I get the performance of those. Okay, I get it here. I already show you that. So that's let me see. So I get the performance of those models here. So based on the data I just generated, I get the performance of those models here. And so now I want to do the stacking. So how to actually do the stacking? I will just make sure I have my base model and also my meta model. So the meta model, the only thing you need to know about that is that by default, it's set to logistic regression for binary classification problem and linear regression for regression problem. So if you want to modify that, the meta model could just be one of your things. It could just be k-nearest neighbor. It could just be decision tree. It could just be SVM. So depending on the thing you want to set up, you just choose. So basically, by default, it's set to logistic regression. So here we are just making the list of all the base model. So logistic regression, k-nearest neighbor, and so and so. But here we are just precising now level one model, which is by default logistic regression. Yes. And then we will just define the stacking ensemble. So the stacking will take as input, yes, the base model and the final estimator, which is the meta model. So it's and as a evaluation method, it will use five cross validation. Yes. So yes, so a list of the model to actually evaluate. So what I want to do here is to compare the result of the stacking model to all the base model. So I want to compare the result of the stacking model to all the base model. So why I'm doing that? Because I want to choose from the performance the best one I will use. So normally it is expected that the stacking model will actually perform better than all of the other, but we don't know, we never know. So just in case it will not perform better, we'll just use one of the base model, preferably the one which will perform better. So those one are just the model we want to use to check about the performance. And here is the complex code about, so it's prepares things. So from the beginning, so importing the libraries and all the things. And yes, so from there, generating the data set, actually defining the base model. Yes. So this is the kind of, I also wanted to advise, so this is the kind of, what to say, modular programming I used to ask you. So Yabi also used to ask you to do that. So if you want to like do something, just think about how to define a function to do it, a function of a class to do it. So any kind of thing, if you think in terms of function or class, it will work better. So so here, there are things I just repeated the thing based on what is done above. But now, how to evaluate the thing? I told you we are using cross validation. So here is how to get actually the score for all the model. But what is more important is this. I wanted to show you that the stacking model is actually here. And from what I see, it's just performing better than all the other models. Yes. So based on that, we just actually choose the stacking model as our best model. Yeah. So it can basically perform more than all. So you see, even the stacking compared to the SVM, which was the first one, yes, we get like some difference in terms of performance. Yeah. So that's what we want. If we are doing competition, we want to get the best result as possible. So that's why I want to you to consider this. Maybe it can be helpful in your competition. You do so basically when you want to do a competition, they are asking you to predict something. You just basically have a start with a small, a very simple model as logistic regression. And from there now you are just adding other complex model as like SVN, bias, and so. And just and by doing that, at the end you could just like before your last submission, you could just like think in terms of yes, what if I try to stack, yeah, to do the stacking model and take my prediction from all the model I just did. Yeah, what if what will I get in terms of performance? It's very important. Yeah. So this is what I wanted to share, and actually, yeah, the stacking model is something exactly at the same level as all the other models. Like it can just be used to make prediction. It can be used to make prediction. Excuse me. So it can be used to make prediction. So when you train your model, when you train your model based on your data, you can just use the stacking model later to make prediction by feeding new data. So this is exactly what we did here. Yeah, so here is all the process again. So how to define the, so define the, how to how to simulate the data, how to define the base model, how to define the meta model, and how to train your model. And here we are just putting a lot new data. So actually from this new data, what is the prediction using the model? Yes. So the model is exactly like all those model, all the other model. So you can just use it to make prediction. And actually, in this case, as it's classification problem, it predict the class 0. Yes. So basically, that's what I wanted to share so far. And I hope you enjoy. So if there is any question, yes, I will be happy to take that. If not, how your competition is going, how the let me see. Three question. The third model in your example has yeah, low performance when evaluated. Yeah, does this lower the final static model performance? Ah, yeah, normally, yeah, because maybe yes, I definitively because it will just use the final model we just use as predictor the output. So if one of the model is actually predicting bad, if one of the model is actually predicting bad, yeah, it will just affect. So if it's a regression problem, yes, it will affect. If it's a classification also, yes, it will affect. So that's why what I will suggest is also to try to the base model, try to select the best one. So if you select the best one, then your final model will just be more accurate. So why actually the lowest model, the model which perform the lowest are useful, because when they are predicting good, we are not sure the best model are actually predicting good. So that's why we want to mix all of them, right? But as much as possible, you could just try to, yes, maybe you don't use model which are not performing at all. Try to use the base model which are already giving satisfactory results, and from there you will do the thing. But do not think in terms of if I'm using a model which is not performing at all. No, definitively when you use those kind of model, it's sure that when those model will predict the right thing, maybe the best one will not do. So that's why I want to combine. But as much as possible, you can just select some of the best at least. So the most, so in the data science, in the machine learning things, if you have a lot of features, it will just help you improve your accuracy. So the number of features depend on the number of models you use. Yeah, so also try to optimize in this side. Yeah. Can we get the link to your notebook? Oh, yes. Yeah. I will share the notebook in today folder. Yes, you will check. I think check it maybe maximum 1 hour after the session. I will just arrange and share, upload it in today folder. And I, I hope it will help you in the competition, because I know this thing is it's really depend on how best your model is doing. So actually combining the result from a lot of model is yes. I experienced it that in the past in my own work, and yeah, I think it performed well. So I think that's why maybe you should consider definitely try to do that. Maybe once we don't know if you do that, and yeah, you can upload to collab and share the link. Oh yeah. Yeah, okay. Yeah, anyhow, I will make it available for you. Yeah, don't worry, I will make it available. I hope you enjoy the session. So normally it should be with Gideon, but he's actually busy doing some other stuff. So I just give this quick talk about that. So I also know it has been a long time now we talk like this, but I'm always following you because I had some other stuff to manage, like your weekly challenge, your grad, your team. So that's why I really appreciate the support of the team, especially Mustafa and Yosman, who are actually fully dedicated to help you. So if any question, just reach out to them. But if there is a need, don't hesitate to reach out to me also. Yeah, we'll discuss. Hope you enjoyed the session, and yeah. So mhm. And good luck for the competition, and manage to win some prize. Even after this week, I wanted you guys, because I saw your result, and yes, you just started on Monday, and on Tuesday you are submitting a very good result. So I think even if we finish this way, you should just continue and win. Try to win this. At least I think you can just make it there after the you can just organize to do like do it like in team. Yeah. So and definitively I think you have the skills to win. You have the skills to win. You have over the skill. You are over skilled to win this competition. So just go. Thank thank you everyone. And this ended the tutorial session.